Hello friends and welcome to the world of free learning. This is Edupedia World and you're watching operations management videos. Continuing our study of the methods of facility location, today we shall take up another important and simple method, that is the break-even analysis method. Now this method is totally based on the economic considerations. As the name suggests, we'll be making use of the concept of break-even to find a new location. You're well aware of the concept of break-even. Break-even analysis basically implies that at some point in the operation, the total revenue equals the total cost. When we start a new plant at a new location, it incurs some cost. And the cost can be divided into two types. One is the fixed cost, which includes the cost for the land, building, insurance, taxes, the equipments and machineries, and so on. And the other type of cost is the variable cost, which is the per unit cost for producing the product, which includes the cost of the raw material, the transportation of raw material as well as the finished goods, the labor cost, the overhead cost, and so on. Now, at a point when when the sum of these two costs, that is the total cost, equals the total revenue, the point is called as the break-even point. Alright, and this method is concerned about finding this point, that is the point at which the revenue and the cost agree exactly. In other words, we can say that break-even point is the volume of output at which neither a profit is made nor is there a loss. So we will go about finding the break-even point for different locations and see which location in the long run would be the most suitable. Alright, so here we would compute the amount of goods required to be sold to just cover the cost. No profit, no loss. Now this concept of break-even analysis could be used for finding a new location only when we know all the costs at each of the locations. If the costs are unknown, then it's not possible to make use of this method. Further, this method helps the manager by giving again a basis of quantitative factor. It gives us, in terms of cost, it gives the manager the choice of various locations. Further, combining it with other factors, they can make use of the method and find the most suitable location. Alright, so how do we go about doing this? We basically plot the total cost and total revenue against the output. Okay, so we will be making use of the graph. We'll have the output in the x-axis and we'll have the total cost in the y-axis, and we'll see, we'll do this for all the various locations on one single graph. Okay, and such a graph you're already aware of is called the break-even chart. So we'll be making use of the break-even chart and we'll be finding the most suitable location. Okay, so without delving much into what break-even point or the concept of break-even or the break-even charts are, because you already know these things, and in case if you have any doubts or if you want to revise your concept of break-even, you can refer to our videos on managerial economics, and we'll go straight away now in using this method and see how the concept of break-even is used to analyze and find the most suitable location. There are basically 4 steps involved. The first is to determine the various types of cost, that is the fixed and the variable cost at all the different locations, and using them we'll find the equation for the total cost. Okay, so the first step is to find the cost at various prospective locations and then get the equation for the total cost. Next, we will solve these equations algebraically to get the break-even points for different locations for all the alternatives. Find, and then finally we will plot these lines or these equations which we have got on a single graph for all the various alternatives, for all the various prospective locations, and then identify the range for each site with the lowest total cost. We'll see in which range, which location gives us the lowest total cost and which is supposedly the most suitable, and thereafter we can decide depending on the range of output which we are planning to obtain from those plans. Alright, and let's take an example. Let's say that the company has zeroed in on 3 different locations. Okay, let me call them as location P, location Q, and location R. Alright, so we have 3 locations, 3 prospective locations, P, Q, and R, and the cost, the various costs. Let's say the fixed, we found the fixed cost and it totals to be say $150,000 for P, $350,000 for say Q, and $950,000 for R. Okay, and the variable cost, the sum of the variable cost per unit, well, this is, let me write, this is per unit, and this is the yearly fixed cost. Okay, the per unit variable cost for at location P would be $10, at Q it would be 8, and at R it would be 6. So now we have both the fixed and the variable cost with us. Next we need to find the equation for total cost. So let me write that here, the total cost. Now how do we find the equation of total cost? It's simply, this is the fixed cost per year and this is per unit, so we will have the sum of both of these, 150,000 plus 10 is for 1 unit. Let's assume that we are going to produce X units. Okay, X units at all of these locations, so it will be written as 10 multiplied by X. In the same way here it would be 350,000 plus 8x, and here it's going to be 950,000 plus 6x. So now we have the equation for total cost for all the 3 locations. For A it is 150,000 plus 10x, sorry, for P. For Q it's 350,000 plus 8x, and for R it's 950,000 plus 6x. Okay, now I need to find which of these 3 are is the most suitable location. Next I've got the cost and the total cost equation. Next I need to find the I need to solve them algebraically and see the break-even point. So let's take first the equation P and Q, sorry, the locations P and Q. When I take P and Q, the equation for P is 150,000 plus 10x, and if I equate it to the one at Q, that is, we are basically finding the value of x. Okay, let me write that here. We are finding the value of x at which, you know, the total cost at which, let me write the total cost as TC. Okay, the total cost at P and Q are equal. Okay, so what is the quantity which if we produce, the cost at location P and at location Q would be equal. So we will have to equate the total cost at P and the total cost at Q. Fine. So the total cost at P is 150,000 plus 10x, that will be equal to 350,000 plus 8x. Okay, so now let me take this 8x to the other side. We will have 10 minus 8 equals 2x, and when this 150,000 goes to the other side, it will be 350 minus 150 equal to 200,000, right? 200,000. So the value of x here would be 100,000 exactly. It's 100,000. So when we produce 100,000 units of product, then the total cost at P and the total cost at Q would be equal. Alright, fine. So this is a break-even point between P and Q. In the same way, let's find the point for the other two, that is for P and R and Q and R. Okay, so for Q and R, when we take, it will be the total cost at say Q equals the total cost at R. The equation would be, at Q it's 350,000 plus 8x, and at R it is 950,000 plus 6x. Again solving them, let me take the 6x to the left hand side. We will have 8 minus 6, that is 2x, equals 950 minus 350 is going to be 600,000. Okay, so now from here we get that the value of x would be 300,000. Right, so for Q and R it's 300,000. What's left out? We've done with PQ, QR, then it's P and R. Let's find out the value of P and R also. So here it's going to be, P is 150,000 plus 10x equals 950,000 plus 6x. So again taking 6x to the other side, we will have 10 minus 6 equals 4x, and then taking 150 to the other side, we will have 95 minus 15 is 80, that is 800,000. So from here we get the value of x, 8 by 4 is 2, is 200,000. So now we have got three values of x. This is the value of x for P and Q, this is the value for Q and R, and this is the value for P and R. Okay, so these are the three break-even points we have got. Next I need to solve and plot them. I need to plot them on a graph. Now to solve I need to get some points, so let me write that here. I have the total cost of P, Q and R. Okay, these are the here I'll be writing the total cost. Let me write the quantity here, x, x. This are the total cost based on the equation which we have. Now when we have, say for example, Q equals, we have got 3 points. Let's first find for those 3 points. When we have Q equals 100,000, the value of P, we have seen that P and Q will be at break even when the value is at 100,000. And when we calculate using the equation we have got here for P, let me write the equation. The total cost equation for P is 150,000 plus 10x. Okay, so when I put the value 100,000 here in place of x, I'll have the value of P equals 1150000. Okay, same would be the case with Q. Total cost of Q is 350 plus 6x, or it is 8x, sorry, it's 8x. And then the total cost of R is 950,000 plus 6x. Okay, I think I'll have to write it. This is for P, we'll have one for Q and R. Okay, so when I calculate for Q again using this equation, putting the value of x equals 100,000 here, we'll get the same value as we have got for P because they are equal. This is the break-even point of these two. And R, when we put for R the value for 100,000, it would be 1550000. Okay, similarly now let's find for 200,000. 200,000, we know that P and R are in sync. So whatever value we calculate for P will be the value for R. Okay, so P, when we put the value of X equals 200,000 here, the value which we obtain would be 2150000, and that will be the value for R as well, 2150000. For Q we will have to calculate, and when we work it out, the value would be 1950000. Similarly, let's find for 300,000. Okay, so for 300,000, and now again at 300,000 we know that Q and R are going to be equal. So let's calculate for Q. Let's put the value of X here in the second equation as 300,000. When we do that, we'll get the value of Q equals 2750000, and so will be the case with R, 2750000. And coming to the value at P at 300,000, this is going to be 3150000. Likewise, you can calculate other values. In fact, if we make use of Excel, this will be simple, and we can in fact draw a chart for various values starting from 0 up to whatever number we want. Anyways, so now let's go ahead and draw the graph for these. So we will have our x-axis will have the quantity of goods, that is in terms of X, and the y-axis will have the total cost. Okay, so now at 0, what will be the values of these at 0? At 0, it's the same whatever we have over here, because the second term will become 0. So at 0, this is going to be 150,000. That is the fixed cost value. This is going to be at 350,000, and this is going to be at 950,000. Alright, so now let's take the scale according to the numbers here. Total cost, we can take a scale ranging from say 500,000, 1 million, 1.5 million, 2 million, 2.5 million, and so on. On the x-axis, since we have got the values for 100,000, 200 and 300,000, let's put it that way, 0, and then we'll have for 100,000 we'll have 200,000, 300,000. Okay, now coming to the first one for P. At 100,000 the value is at 1.15. At 0 it is 150. 150 would be, let me take another color, 150 would be somewhere over here. At 100,000 it is say 1.15. that will be very close to the value here, somewhere here. Okay, and then just 2 lines we can extend it further. Okay, so okay, we'll get a graph something like this. Now the graph here, since I'm doing it using hand, may not be the most perfect one. We can get it on the Excel sheet, but let me first explain it to you here, and then we'll go with the Excel sheet. In the same way, the second one, that is for Q, the line would be starting at 350, which is again somewhere over here. Let me take a different color for this. 350 would be here, and then it will be meeting X at this point. Okay, it will cross over and go to the other side. Alright, and finally with the third one, that is, let me use another color for that, Q, starting from 95, which will be here somewhere around this point, 95,000, and then that meets your R meets your P at 215, right? R meets P at, let me just, so it'll meet P over here, and it'll meet Q at this point. So this line Q will go something like this. Alright, so now we have, you see, this is the first point here where two of these are meeting. Okay, this is the second point over here, and this is the third point. Now we'll have to see in all of these ranges which will give us the lowest value of the total cost. So we see if we produce from 0 unit up to say 100,000, okay, in this range, that is from 0 to 100,000, which is the best one? The best location is P, the first location. Okay, P is the best location. Whereas moving from 100,000, okay, from 100,000 to 300,000, we see that this location is the most suitable, and this is your location Q. And beyond that, beyond 30,000, sorry, 300,000, 300,000 and above, it is the third location, that is R. R is the most suitable. Now the company will have to see and decide based on what is their total annual output. If their total annual output is going to be less than 100,000, they'll have to go for P. If it is between say 100 to 100,000 to 300,000, then they'll go for Q. And in case if it is greater than 300,000, then the most suitable would be R. Alright, so this way the graphs can help us. The concept of break-even analysis could be made use of to get the values. Let's do this very quickly on an Excel sheet. Here we have the three costs for the three locations, fixed and variable cost. Okay, let's very quickly find the values for various quantities. Let's put the equation for P. It's going to be 150,000 plus 10 multiplied by the value which I'm going to put here, the X. Okay, the same way for Q, it's going to be 350,000 plus 8 times the value which I'm going to put here, and R, it's going to be 950,000 plus 6 times the value which I'm going to put over here. In Excel we'll get a better graph and you can have a look. Okay, now let me drag this down to the values till the last, and then we'll put the various inputs for quantity. Okay, so now let me put the values here, the quantity, and let me put it in intervals of 25,000. Okay, the higher the interval you give, you will get values for up to higher values, but we need to get a clear picture of our range, which is between 100,000 to 300,000. Okay, so let's try this 25,000, then 50,000 and so on, and let's see whether we get the range in this or not. In case if it is not, then we can change the scale. Alright, so we have it. Yeah, we are getting, see, 10,000, sorry, 100,000. We see exactly that the values at P and Q are equal. When we look at 20,000, we see that the values at P and R are equal, and it's the one which we got while solving algebraically. Okay, and then at 30,000 we see that the values at Q and R are the same. Alright, so now let's get the graph quickly for this set of data. Let's get the graph on one single sheet for all the three locations. Yeah, here we have, let me just enlarge it and we can have a better view of well, you can see here now that this blue line represents your location P, the red one is your location Q, and the green one here is your location R. We see that if it is in this range up to this value where these two are meeting, then P is the most suitable, and this is the 10,000, 100,000 mark, fine here. And then beyond that up to 300,000, it's the red one, that is the second location, location Q, which is the most suitable. And finally beyond that, beyond 30,000 point, 30,000 mark, it's the green one, which is the location R, and that's the most suitable. Alright, so that's all we have in break-even analysis method. Here you have two more questions for you to practice, and this time it's your assignment question. You'll have to solve it yourself. The first one is that a businessman is planning to open a factory in one of the following three cities to produce high quality electronic components for computers. The relevant data are given as follows. You have location of A, B and C, three different cities. The fixed and the various variable costs are given. You need to find the following. The first one is to represent the cost graphically. You have to draw the graph of this. Okay. Next is over what range of annual volume is each location going to have a competitive advantage. You need to tell which location is most suitable in which range. And finally, what is the volume at the intersection. So it's exactly what we did today. The second question is that an operations manager has narrowed the search for a new location to 4 communities. The annual fixed cost and the variable costs are shown below. You need to plot the total cost curve for all the communities on a single graph and identify on the graph the approximate range over which each community provides the lowest cost. Calculate the break-even quantities over the relevant ranges. If the expected demand is it's 15,000 units per year, which is the best location? So here you need to tell if the annual demand is going to be 15,000 units, which of these 4 would suit the most. So these are the questions for you to solve yourself. If you want a solution, we'll be giving you the solution in the next video. Keep watching Edupedia World videos. Thank you. And for more videos, you can log on to our website www.edupediaworld.com, and in the Learn section you can find videos on various subjects. You can also refer our videos to your friends. Thank you.